Hi guys, it has been a long while I last updated my videos. So today we are looking at a new chapter called Differentiation of All. So without further ado, let me go to the first slide. So over here we have some trigonometry terms. So we need to learn how to differentiate trigonometry terms. So let's do part A. So we have y equals to 2 cosine bracket 4x plus 1. So to differentiate this, we know that cosine x, differentiation of cosine x gives us minus sine x. Therefore, I have 2 times minus sine bracket 4x plus 1 bracket, and I still have to differentiate the bracket 4x plus 1, which gives me 4. Therefore, my final answer is minus 8 sine bracket 4x plus 1. And probably you are seeing me writing down differentiation of all trigonometry terms. So in fact, it's a good practice. Before you do differentiation of trigonometry terms, it's a good practice for you to write down all these differentiation of sine x, cosine x, and tangent x. So it becomes very handy when you need to differentiate trigonometry terms. So over here, let's do part B. So you have to transform your part B to what I have written. So this is nothing but you can differentiate using chain rule. Bring down the power minus 1, and not only that, you have to differentiate the term inside the bracket. Tangent bracket 4 minus 2x, you have to differentiate this, and that will give you secant square bracket 4 minus 2x. And not only that, you have to differentiate the 4 minus 2x, which gives you minus 2. So in fact, I'm trying to show you have 3 terms which you need to differentiate here. First, you differentiate the one in gray, and next you have to differentiate the one in green, and lastly you have to differentiate the one in blue, and you have to multiply the results of them all. And therefore, if you combine them, you get minus 6 tangent square bracket 4 minus 2x times secant square bracket 4 minus 2x. You can continue to simplify this, but I don't see a need to do so. Therefore, I will leave it as it is. Now, let's move on to part C. So part C, I have x squared, and I also have sine bracket pi x over 3. And clearly, you can see that you have a x squared, which is your u, and you have your sine bracket pi x over 3, that is your v. So in fact, a lot of students, if they are unable to identify u and v, but actually it's very simple. Whenever you see 2 terms and they are both with x, and definitely that is your u and v. So you continue to differentiate your u, and you go and continue to differentiate your v. So if I differentiate u, I get 2x. If I differentiate v, I get cosine pi x over 3, and I have to differentiate the pi x over 3 inside, which gives me pi over 3. And therefore, after that, I cross multiply. Therefore, I can get my dy dx. So this is differentiation using product rule. So remember, don't skip steps. My experience tells me students that always skip steps tend to make mistakes, and therefore you should get your result. And now we have come to a new slide which shows you some logarithm function. So on this slide, we will learn how to differentiate logarithm function. But before that, you should know differentiation of logarithm function. So probably I will write that down first. So in fact, differentiation of ln x, it gives you 1 over x. Therefore over here, ln bracket 2x minus 1, you will get 1 over 2x minus 1. And once again, you have to differentiate the one in green as well, which gives you 2. And therefore, you just combine them. So you have 2 over 2x minus 1. So I have finished my part A. Now, let's continue to take a look at part B. And once again, I have a logarithm function. And clearly you can see I can bring down the half before I differentiate this term. So I bring down the half, and I can also factorize my 4x squared minus 1, and that gives me bracket 2x minus 1 and bracket 2x plus 1. And as you can see, you can use logarithm, the product law, so you can actually split it. So therefore you will get what I have written. So this is very simple, and I'm writing down the product law. If you have ln x times y, it is equal to ln x plus ln y. And similarly, if you have ln x over y, which is equal to ln x minus ln y. And therefore, you can start to differentiate your y. This is differentiation using, so this is differentiation of individual terms. So go ahead and differentiate it, and you should get answers exactly like mine. And let me continue to simplify these two terms. Therefore, your answer should be 1 over 2x minus 1 plus 1 over 2x plus 1. Simple, right? And now, let's move on to part C. Okay, remember, differentiation, we have learned differentiation of individual terms. Second type, using chain rule. Third type, using product rule. That's all we have learned. So now, let's move on by using the rule above, ln x over y. So therefore, you can actually differentiate term by term. So you will get y equals to 2 ln 3x minus ln bracket 2x minus 1 after using the rule above. So now, let's go ahead and differentiate term by term. So you differentiate your ln 3x, you should get, oh, in fact, you can even simplify it further before you do the differentiation. As you can see, ln 3x is nothing but similar to ln xy, which gives you ln x plus ln y. Therefore, don't differentiate first. Simplify it further first, so that you have individual terms. Differentiation of individual terms is always preferred. So now, you have a constant 2 ln 3, which gives you 0 after differentiation. 2 ln x gives you 2 over x. And differentiation of ln bracket 2x minus 1 gives you 2 over 2x minus 1. So you will get the result. And now, we have come to a new slide which shows you some exponential terms. So before I continue, let me write down the standard differentiation of exponential terms. So differentiation of e to the power x gives you e to the power x ln e. Since ln e is 1, therefore you get e to the power x. So it's simple. So you are given part A. So let's expand it first. So you will get e over e to the power 3x. And e is actually a constant, like a pi. So whenever you differentiate, you can actually take out the constant. And then after that, you times it back. So for this part, I just have to differentiate e to the power minus 3x. So dy dx should be equal to e times e to the power minus 3x, and you have to differentiate minus 3x, which gives you minus 3, right? So therefore, you will get e times e to the power minus 3x. And not only that, you have to differentiate minus 3x, which gives you minus 3. Therefore, you combine them back, you should get minus 3e times e to the power minus 3x. In fact, you can simplify it some more, but I don't think it's necessary, so I stop at there. So now, let me continue to do part B. You are given e to the power of sine 3x. And clearly, this is easy. So your dy dx is, so you differentiate e to the power of sine 3x, you get e to the power of sine 3x. And not only that, you have to differentiate your power sine 3x, which gives you cosine 3x. And you have to differentiate your 3x, which gives you 3. So I'm showing you the step. First, you differentiate the one in green, and next, you have to differentiate the one in blue. And lastly, you have to differentiate the 3x, which is in gray. So after you differentiate these three terms, and you have to multiply their results together. So now we have come to part C. So part C, clearly you see two terms, and each term they have x. Therefore, you have to use product rule. You have u and v. So differentiate u, you get 1. Differentiate v, you get e to the power of x to the power of 2. And not only that, you have to differentiate your x to the power of 2. That will give you 2x. And now you can, but before that, what I can do, let me rearrange and make it look nicer, so that when I cross multiply, it's easier to see. So my dy dx is, so 1 times my v, which gives me e to the power x to the power of 2. And now, plus, you should get 2x squared times e to the power of x to the power of 2. So that's the answer. Definitely you can continue to simplify it some more. You can actually take out the common factor e to the power x to the power of 2. But that's up to you. If the question asks you to simplify your answer, continue to simplify. If the question never asks you to do that, you can leave it like that. Okay? So, we can move on to the next slide. So on this slide, we are given a function y equals to cosine x over sine x minus 2. And we are asked to show that dy dx can be expressed in the form as such and state the value of p and q. So, to do that, I'm not familiar with quotient rule, or rather, I do not like to use quotient rule. I can use product rule to solve this, to find my dy dx. So I bring up my sine x minus 1. Therefore, I get my u and v, and I continue to differentiate my u and v. So du dx gives me minus sine x, dv dx, bring down the power minus 1, bracket sine x minus 2 to the power of minus 2. Because you bring down the power, you have to minus 1. And not only that, you have to differentiate sine x minus 2. That should give you cosine x. So, now I can actually cross multiply and get my dy dx. So, my dy dx is sine minus sine x over sine x minus 2. Plus, but over here I get minus 1, therefore minus cosine x times cosine x, which is cosine square x over sine x minus 2 to the power of 2. And over here, I have to simplify this answer because the question requires me to express it in certain form. And therefore, I get minus sine square 2x minus 2 sine x. And actually, I should get minus sine square x plus 2 sine x minus cosine square x over sine x minus 2 bracket square. So the result is derived by making the denominator the same. So let's simplify the question further. I will get minus 2 sine x plus 1 over sine x minus 2 bracket to the power of 2. So from here, I can clearly compare this term to the form given in the question. My p is equal to 1 and q is equal to minus 2. In part 2, it says hence find the value of x between 0 and 2 pi for which y has a stationary value. When question asks you to use hence, you have to make use of the results in the previous part. So when y has a stationary value, which means you equate your dy dx equal to 0. And you should see that, which gives you minus 2 sine x plus 1 equals to 0. Sine x equals to half. If you're familiar enough, sine x equals to half, that gives you x equal to 30 degrees. But over here it says 0 and 2 pi. This also means 0 to 360 degrees. So you will wonder why I know sine x equals to half, x should be 30 degrees. Actually, you can actually sketch this special triangle out. So once your x equals to 30 degrees, and you know that the other angle is 180 minus your x1, so you get another angle which is equal to 150 degrees. And if you change them to radian mode, you should get x equals to pi over 6, and you should get another 3 pi over 2. 3 pi over 2 should give you 180. And we have come to the end of this chapter. So see you again. Bye.